The most expensive problem with your electric vehicle can start with a small part that no one pays attention to. In this video, I explain the 5 major mistakes most drivers make without realizing it. If you want to protect your EV from silently developing problems, you absolutely must avoid these mistakes. 1. Cooling system blockage. Most electric vehicle owners talk about the battery, motor, or software, but very few notice the component that silently protects all these systems: the cooling system. Every critical part, from the battery to the inverter, from the motor control unit to the charging circuit, must operate within a stable temperature range. What maintains this balance is the seemingly simple but vitally important cooling circuit. Over time, dust, sediment, metal particles, or air bubbles can enter this circuit. Especially with prolonged use, microscopic dirt accumulations form in the fluid line. At first, you only notice the fan kicking in a little more often. If ignored, this situation then leads to temperature warnings during charging, sudden power drops, and performance limitations. This is because the battery can no longer be kept at its ideal temperature. This situation is not just a loss of performance. It also disrupts the balance of the cells. Overheated battery segments gradually lose capacity, and some cells become permanently weakened. The same risk applies to the motor and inverter. Without adequate cooling, conductors expand and solder joints develop microcracks. The solution is simple, but most users neglect it. Have the coolant checked at regular intervals. Have the fluid changed and the fan and radiator cleaned according to the manufacturer's recommendations. Even checking under the vehicle during the summer months for dry leaves, dust, or insect remains can make a difference. Remember, overheating in electric vehicles is a problem that starts silently but can be costly. The cooling system is an invisible safeguard. Taking good care of it will extend the life of your battery and range. 2. Suspension fatigue. Electric vehicles are quiet, vibration-free, and smooth. But beneath this comfort lies an unnoticed weight. The average EV is 450 to 900 pounds heavier than a comparable internal combustion engine vehicle. This extra weight constantly bears down on the suspension components: shock absorbers, sway bars, bushings, and mounting points. Most drivers don't feel this pressure beneath the EV because the cabin is quiet, the noise is hidden. But over time, small bumps, potholes, and speed bumps increase the suspension's metal fatigue. When you hit a hard pothole, that impact is reflected not only in the tire but also in the carrier connections of the hundreds of pounds of battery packs. The result? Microscopic deformations, bushing cracks, leaks in the shock absorber seals, and increasingly noticeable knocking sounds. At first, you only hear a small thud. Then the steering response changes, the braking distance increases, and even the range noticeably decreases. Because every vibration absorbs energy, every impact affects the engine's efficiency. The way to protect it is simple but requires patience. Slow down, release the brakes in advance when approaching bumps, and pass over potholes at an angle. This is not just about comfort, but about protecting mechanical life. Additionally, maintaining tire pressures at the manufacturer's specified levels is critical for balancing the suspension load. Suspension fatigue is not a sudden failure. Each impact weakens the structure over time. And in EVs, this effect progresses silently, unnoticed. Having a few shock absorbers checked in time can save you thousands of dollars in repairs down the road. 3. Excessive tire wear. The first thing you notice in electric vehicles is the silence. The second is torque, instant, uninterrupted power. However, this enjoyable acceleration eventually becomes the tire's greatest enemy. In EVs, the motor's torque is transmitted directly and instantly to the wheels. This happens without revving up the engine or mechanical delay, unlike in conventional fuel-powered vehicles. The result? The tires practically stick to the surface, causing microscopic fragmentation. Moreover, EVs are on average 20 to 30% heavier. This extra mass creates high friction on the shoulders of the tires during every acceleration, every turn, and every sudden braking. A tire that is not at the correct pressure cannot handle this load. Wear begins on the outer edges, followed by deformation of the inner layers. Over time, range decreases, road noise increases, and energy efficiency is lost. If the alignment or balance is off, the situation worsens because an improperly aligned tire cannot press evenly against the surface. Especially on front tires, uneven wear manifests as steering vibration and pulling. This threatens not only driving comfort but also safety. Prevention is quite simple but requires regularity. Check tire pressure every 2 weeks using a digital gauge if possible. Have the alignment and balance checked during long trips or seasonal changes. Also, avoid high torque starts and be gentle with the gas pedal. Remember, tires in your EV determine not only road grip, but also energy efficiency. At the correct pressure, balanced tires roll with less resistance, saving both your battery and your wallet. 4 motor bearing wear. Rotor bearings. Electric motors are quiet, vibration-free, and operate with almost no maintenance. But this perception of endless durability misleads most drivers, because at the heart of the motor is a constantly rotating component, the rotor bearings. These small but critical parts support the entire power of the vehicle, while rotating tens of thousands of times per minute. And every overload, every sudden stop-start, silently chips away at their lifespan. In EVs, transitioning from high speed to sudden deceleration or constantly stopping and starting in traffic puts serious stress on these bearings. This is because electric motors deliver torque instantly, which places a huge load on mechanical balance. Over time, bearings develop microscopic imperfections. These imperfections increase vibration, damage the friction surface, and eventually lead to metal-on-metal contact. The first signs are very subtle: a slight hum, rhythmic vibration at low speeds, or a faint noise that increases as you accelerate. Most drivers mistake this for tire noise. However, at this point, deformation has already begun on the bearing surface. If this continues, the motor shaft loses alignment, efficiency drops, energy consumption increases, and eventually the motor's internal structure is damaged. To prevent this, avoid sudden speed changes and use the gas and brake pedals evenly. If you need to drive at high speeds for a long time, allow the engine to cool down afterwards. Additionally, having a motor noise test or vibration analysis performed at regular intervals is the only way to detect the problem early. Rotor bearings are not cheap parts, but noticing the warning signs beforehand is free. A careful ear and calm driving can prevent thousands of dollars in repairs. 5. DC-DC converter failure. At the heart of electric vehicles lies a high-voltage battery. However, the vehicle's daily systems, headlights, multimedia, window motors, locks, operate on 12 volts. The invisible bridge connecting these two worlds is the DC-DC converter. In other words, it is a silent power regulator that converts high voltage to low voltage. This small box is as critical as the vehicle's brain. When it malfunctions, your car can suddenly go into ghost mode. The screen goes blank, the locks stop working, and the systems shut down one by one. So why does it malfunction? One of the most common reasons is a weak 12-volt battery. Imbalances or low voltage in the battery cause the converter to operate under excessive load. Additionally, sudden torquey demands, aggressive driving, and abrupt energy transitions, e.g. full throttle acceleration after regenerative braking, impact the DC-DC circuit like a shock over time. Internal circuit components overheat, solder joints weaken, and capacitors lose their capacity. The first signs are usually minor and confusing: brief warning lights, slow wipers, multimedia system resets. Drivers often mistake these signs for software errors, but the system is actually struggling with low voltage.